Guys, let's wait for 5 minutes before we start.
We'll be starting in 5 to 10 minutes, sir.
Sure, cool. I hope my screen is visible okay.
Yes, sir, it's visible.
Cool. Okay.
हेलो।
Cool. So we have 1 minute left. So I just wanted to understand that this audience is already aware of generative AI, right? What is Gen AI, machine learning, and artificial intelligence? If that's not the case, then I will take a few minutes to explain that at very high level. So anyone in this group who has not been through generative AI concepts or artificial intelligence concept, please let me know. I'll just cover it at very high level quickly.
So the target audiences comes from both the backgrounds actually.
Mhm.
So it would be better like if you would give a chance to like from the introduction part itself because few freshers are also there in the target audience.
Got it. Okay. Okay, cool. So I think it's 7 already. Should we wait or should we start? Okay, so let's start. Um, let me let me explain you the some ground rules which I want you guys to follow so that we can have an effective session here. So I would like you to mute yourself, all of you. If you need, if you want to raise any question or ask any question, please raise your hand. And then once I'm like through with that concept, then I will take the questions. So please raise your hand before you speak. That way we can maintain the order in the class, in the session. um,
Sorry to interrupt, sir. Sorry to
yeah.
interrupt. So actually, we would just like to give your introduction to the target audience. So just a few minutes. Madhulika, can you please give the introduction of the sir to the audience?
Yeah, sure, ma'am. Sure. Good evening, everyone. Hi, this is Madhulika, student of Data Science and Generative AI, October 2025 batch. It is a great pleasure to welcome our guest speaker, Mr. Gaurav Bhatnagar, sir, co-founder and CTO, and an accomplished leader in AI and technology. He brings over 17 years of rich experience and has worked with leading global companies. Sorry, disconnected. Hello, is my voice audible?
Yeah, Madhulika, go ahead.
Sure, thank you. So, Gaurav sir has played a key role in building large scale AI systems that solve real world business problems. His work has helped organizations improve efficiency, reduce operational cost, and enhance decision making through the use of advanced technologies like machine learning and cloud computing. He has led high performing team driven innovation and contribute to impactful projects across the finance, advertising and enterprise technology. He is also a US patent holder, which reflects his strong commitment to innovation and excellence. Beyond his professional achievements, he is passionate about guiding startups and sharing his knowledge with aspiring professionals. His journey is truly inspiring for all of us who wish to build career in technology and leadership. We are honored to have him with us today. Let us warm welcome to Mr. Gaurav Bhatnagar, sir. Thank you, sir. Over to you.
Thanks, Madhulika. I think thanks for the nice words. I just want to add one more thing to the intro, that I have started working on artificial intelligence when I joined Amazon. So I have worked with Cisco and Amazon for almost 10 decades. So uh, and I have started when there was nothing. It was just machine learning and basic structured data, and have seen how this entire thing has grown from a very tedious way of working on machines, and then to a simpler way of working with generative AI. So let me start. So I think introduction is already done. So let me go to the next slide. Okay, before I was not actually thinking of giving too much detail on the generative AI, but let me tell you guys that what is artificial intelligence. In a broader sense, artificial intelligence is the science where you teach machine to behave like humans. Okay, so there are some cognitive tasks which humans can do, but machine cannot. So, like for example, if let's take an example of images, right? So, computer vision, where if human sees a cat, it can recognize this as cat, or sees a dog, it can differentiate between cat and dog. So, doing that kind of differentiation is artificial intelligence. This is like simplest thing which I told you, and there we do once we go through this presentation, we'll get to know more and more complex tasks, how artificial intelligence has evolved over a period of time. So the first thing which we started long back in 1970s is machine learning. At that time, we talked about that how machine can learn and things like that, but at that time we didn't had a lot of data. There was no networking, there was no compute to process that much data. So the concept existed from 1970, but it started getting more traction once we started having more bandwidth, network bandwidth, more data accumulation. We got smartphones, people are generating content, and then later the network speed and compute also increased, and it became available to everyone through AWS, through cloud computing and all. So that way, artificial intelligence concept was not new. It was introduced very in very early 1970s, 80s, but it was started in 2014 and onwards, and after that it took a exponential growth. So an artificial intelligence, first thing is machine learning, right? So machine learning is a broader concept. Inside that, where you have two kind of machine learnings. One is called structured with structured data, supervised learning. What that mean is, so there are two kind: supervised learning and unsupervised learning. In supervised learning, you tell the machine exactly what it needs to do. So for example, let's take both cat dog example. There you give machine that of cats, and give machine images of cats and dog, and label it that these are cat images, these are dog images, and it learn from that. So that is called structured labeled supervised learning. And then something called unsupervised learning, where you do not label it, and you can simply give this all the images to the system to learn about it automatically. So this is a broader concept. I'm just giving you very high level, but we can get into details maybe in future sessions. But this is supervised learning, means you have labeled data. Unsupervised learning, where you don't have a labeled data. And unsupervised learning actually it evolved into deep learning, where the concept of neural network came in, and then neural network is like the way we learn. Like our brain knows we have neurals, and these neurals are interconnected, and each neural is one knowledge, and then connected neural network is related knowledge. So that is deep learning, where we introduce neural networks. So that's called deep learning. Again, this is a subset of machine learning. And another subset is which is recently came in. It's not so recent, but comparatively recent, generative AI, right? So generative AI started with LLMs, large language models. In that, we have transformers kind of model. Again, I'm giving you this concept. This is not so simple to explain, but I'm just giving you high level so that you can go and learn about it. So transformers has two parts, decoder and encoder, where information given is decoded and then put in one form and then re-encoded at the time of inference. Uh, so that is a transformer, and this where generative AI started. Why generative AI? Because the generative word is previously the machine learning model was not able to generate anything. It was just classify, it was able to classify or cluster or give very specific tasks. In case of generative AI with the LLMs, large language models, it's able to generate new content. You give it a prompt, and it will be able to, if you just give a prompt, like, okay, write a song about something, it will just write that. So generative AI is about generating new content. So that's where I wanted you to understand at very high level. If you have question right now on any of this topic at very high level, then we can talk about it. And after that, I'll move towards the agentic AI. Please here raise your hand if you have any questions, or you want me to talk about something little bit over in more detail. Okay, so I'm assuming there's no question. Okay, so let's start with this agentic AI and multi-agent system. So multi-agent system is also called MAS, MAS. Uh, so think about, what if your software didn't wait for any instructions? So how you code right now, you write an algorithm, right? You write that, okay, a simple example of adding two numbers. You give instruction that, okay, input the number A, input number B, and then add two numbers, and then output is stored in a variable C, and print that. So this is something which we do right now. But that is a past thing, where you have to write the instructions and computer executes that. This transition where you don't tell software exactly what to do is happening right now. If you look at this image, a human is giving a command to a chatbot, and chatbot in background is talking to multiple AI agents to do a task, and these agents are talking with each other to execute a task. So that's what is happening right now. So if and it has evolved very rapidly in last 1 year, where we in late 2024 we had just generative AI, but now in 26 Q1 we are already talking about deploying multi-agent models in field. Okay, so I'll talk about more into this, and let's go towards that. What is how we are proving that this is going through? So 40% of enterprise app will embed AI agents by end of 2026. It is 5%, greater than 5% up from 2025. 1445% surge. So you can imagine the number here in enterprise multi-agent system inquiries from Q1 2024 to Q2 2025. So this is a Gartner data. The latest data has not come yet, but this is what we have seen in 1 year. 40% of agentic AI projects will fail by 2027 due to poor governance. Governance is a very critical thing in this, because if we don't control how agents are working, it's going to be very difficult to debug the system. So governance also I'm going to talk about. Cool. Any questions so far before I move forward? Please raise your hand.
Sir, I have only one question, sir.
Mhm.
Sir, because of AI coming, some jobs are very dangerous to get it. Uh, how it is solved for life?
See, this is a myth. It's not like that if generative AI comes in, then your job will go away. It is not like that. But your job will go away definitely if you don't learn it how to work with AI. So assume generative AI or agents are very intelligent students, right? They know how to do things, but you need a teacher, you need a guide to tell them exactly what to do. So there will always be human to be there to explain how things should work. So you will learn about it, means we'll go forward, we'll learn about it. So it is not like that is going to take away your job. It will take away your job if you don't learn generative AI, because you how to control generative AI is a human task. It cannot be totally given to the machines. Am I able to answer a question, Subhaji?
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir, for that clearing me, sir.
Cool. Okay, moving on. So this is what we are going to do today. So we will talk about why now, why this is happening now, right? Why it didn't happen earlier. I think I covered a little bit of it earlier, but we'll talk about that. After that, we'll talk about what is agentic AI. Then I'll tell you how to architect it. Then I'll tell you what breaks in production, what nobody is going to tell you, which you have to take care when you are building the system, and what you should do next to learn more about it. Okay, so this is the plan, today's plan. Okay, moving on. Why now? So three enablers, this shift the entire thing in last 18 months. What are these three enablers? MCP is, if you guys are aware of it, it's called Model Context Protocol. Anthropic is a huge company into generative AI. They have launched Model Context Protocol. What it does, it actually standardized tool access. So I'll explain you what is tool and all that, but I just keep that in mind that this is something which actually changed everything. Previously, we had to do custom integrations per model, but it has to be specific for each one of them. But now with MCP, you don't need to do that. After that, Google came up with agent to agent protocol. So this again, where two agents can communicate with each other. Previously, there has to be an orchestrator algorithm which defines how these two agents talk to each other. But now two AI agents can talk to each other using this Google protocol. Now with this, you can have cross-platform agent interoperability. What that means is that if there are two systems running across the internet, it can talk to each other and work together. SLM, small language model, micro agents have come. So currently LLM models are huge. Like you need big machines to run those models. But with evolution of small language models, we have a small fine-tuned model which can be done for a specific task. I'll give you an example which I'm going to working on, so that you understand what SLM can do and how it is changing the entire landscape. And it's also reducing the cost of LLMs, which is super costly if you take huge latest models. So, okay, so whatever you are seeing right now is being subsidized, but actual cost is huge. Okay. Any question on this slide before I move forward? Okay, I'm assuming no. Okay, so why now we discuss now what is agentic AI? Okay, so let's go towards agentic AI. If you have worked on software, you must have seen this microservices, right? So this is a similar game, but in a different way. So microservices, what we do, if we divide a large problem into small uh, uh, problems, and then those small problems, you solve that problem using a solution, a microservice, and they work together to create a big system. Okay, so this is what is microservices, which we are working on since last 15 years, where you have a software, you have APIs, you have multiple microservices running in cloud. They're working together to give you a solution. For example, Facebook, Twitter, they have multiple microservices working together. So similarly, in agentic AI, we are doing the same thing here. Is we are dividing the bigger problem to smaller problem, and then each smaller problem, is given to one agent. It solves that problem, working with other agents to solve the bigger problem. So this is something which is not new. It's just that we have used agentic AI, or we have used agents, artificial agents, in a different way altogether. Okay, let me move on. So there are 5 capabilities that define an agent. What is an agent? Um, Anyone can answer this question? What is an agent? What do you know about the agent? Anyone? Any vague idea? Okay. Uh, how a human work? So how a human work? They, let's say, okay, let me take a very
Hi, good evening,
interesting.
sir.
Sorry, you want to say something? Anyone?
So I'm telling about the what is agent.
Yeah, yeah. Please go ahead.
So agent means the person whose job is to do business for a company or for another person's.
Yeah. So that is in context of generative AI. That is partially true. Means yes, agent is working on behalf of the overall system, and it does a very specific task. In your analogy, Ganesh, is like if a agent is given a task of, let's say, getting some paper signed, right? If, let's say, you are in real estate business, and then you have n number of things to register a property, then an agent goes and does one task. One person goes and get the stamp paper, another person goes and then get the signatures, another person goes and book the registrar slot and all that. So each agent has a very specific task. So similarly, this is how agents are defined in artificial intelligence world. Now, anyone, a human or any agent, how it works. First, you perceive that what is a problem, right? And how you perceive, you have sensors. In human, we have sensors like we see, we hear, we taste, we touch. So all those are perceptions. In the machine world, the sensors are cameras, right? You have a mic. So to hear, to as of now, there is no taste sensor yet popular so much, but we have those two sensors to perceive. So for example, if let's talk about the same cat example, where a system is there which recognize the object. Okay, artificial intelligence, the task is to identify the object in a scene. So what it does, first it perceive the scenery. So with the camera input which is coming in, if he sees a cat moving, so it will first perceive it through the visual, that there is a visual, there is something there. And what is that object? That is the second part, reasoning. It reason it. Okay, that okay, this is a cat. Now this is a cat, and then it has to. This should not be here, right? So what I should do? So for example, in the agent, you have given a command that whenever you see a cat, you sound an alarm. Then it acts. So it reason that okay, because cat is there, I have to sound an alarm. So that it reason that and take an action. How it does that? It uses memory, it uses tool, and finally it takes an action. So how in this context, what is memory? In memory, it will store that okay, there is a cat, and then tool is sound the alarm. So there is a tool, there is a system which actually, if which agent can use to sound the alarm. So that is the tool. So agent always work with tools which does something. It could be a program, it could be algorithm, it could be any other sensor trigger, anything can be there. Any questions on this? Because this is a very important concept. When you understand agent, these 5 capability are required to define an agent. Did you guys understand this?
Yes, sir.
That agent has memory, agent has reasoning. So it perceive, it retake, it reason, and then finally it takes an action. How it takes an action? Using memory and tools. It memorize everything. So in generative AI, when you write a prompt, it does one thing and after that it forgets. But agent remember what you have done earlier. Okay, so that's the difference between generative AI. There's a key difference between generative AI and agents, where agents have long-term and short-term memory. It learns, it understands based on the past experiences. Okay, moving on. So why we are getting into multi-agent? Why one agent cannot do anything? So think about your team. Wherever you are working, you must have somebody who's a superstar, right? But do you think that that one person can do everything? Even if he's superstar, he know everything. Still, he'll not be able to do everything. So we have a team. We have a team of engineer. We have team of different people working together to complete a task. So this is where the multi-agent system comes into picture, where you have a supervisor agent or orchestration agent, which assign tasks to different agents. Agents might have sub agents, so there will be a hierarchical relationship between them, and then each agent does a very specific task. So agent, when we architect agent in artificial intelligence world, it does one specific task. It cannot do more than one task. That's how the entire system works. If we don't do that, then it drifts. So there is a concept of uh, drift. Means if it's supposed to do X, it start doing something else which is not supposed to do. If you try to do everything using single agent. Okay, we can actually talk about this in more detail, how that happens and all that. But in interest of time, let me move forward. Any questions on this? Okay, moving. Okay, now how an agent thinks in continuous cycle. We just talked about it earlier. It observes, so it look at the sensors. It listens to voices. If you have a microphone, So for example, Alexa, right? What it does, Alexa, when you speak, then it takes that input through the mic, and then it that is observation part, and then it it converts that voice to text command, English command, and then that English command orient reason exactly what we are asking it to do, and it decide, okay, based on my orientation, based on the reasoning, it, let's say I have said play music or play let's say Hanuman Chalisa. So in orient, it understand that I have to play some music, and exactly what I have to play, Hanuman Chalisa, and it decide that which that Hanuman Chalisa audio I have to play, and finally it acts, it start playing that. So this is how agent work. It observes based on the sensory input which is coming in. It reason that what that input mean, and based on that, what is the best action it should take, and finally it takes an action. So agent does end to end one full cycle. Okay. Now I just explained you what is agentic AI. If you have any questions, I'll pause and then we can take that.
Hello.
Yeah, Shekhar, go ahead.
So my question is how agent is different from normal AI, or like we are moving in today's world with AI, how agent will act there?
Okay, so currently, have you used ChatGPT, right? Well, when you use ChatGPT, or for example, Google Gemini or Perplexity or any generative AI system, what you do, you just write a prompt, right?
Yes,
You
sir.
say that I am get me all the agents, all the travel agents in the world, right? And it
Yes,
searches and gives you some answer, right? It's one prompt.
yes, sir.
Okay. So generative AI does only that, means it goes to LLM and then it takes the query, it gets the answer. After that, it stops. It does not reserve the context. Agentic AI is that if you ask that um, you ask about the agent, and after that you ask another question that, okay, tell me which agent can help me booking the train. So it understand the concept, and then it understand the context, and it keep that context with that, and then keep on asking more questions to perceive it. Behind that, there are multiple agents. So for example, let's just take one of this travel agent only. You have different type of travel. You did be bus booking, travel booking, flight booking. For these three, there are separate agents which work in background. So previously, when you use generative AI, it is just that you ask one prompt and then it gets you answer. Now with agents, you can take action, and then to take that action, each agent take responsibility of that. Am I able to answer your question, or should I explain more on that?
Yes, sir. Yes, sir. I'm getting.
Cool.
Okay.
Okay. Any other question, anyone? Cool. Moving on. So let me explain you how to architect it. So there are different kind of pattern. Then when you write software, there are different kind of design pattern. If you remember, so like you have command pattern, you have fishbone pattern, you have different kind of patterns which pops up model. The multiple kind of design patterns which we use uh, in our software design. Similarly, in agentic AI, we have different kind of pattern. So for these are four different patterns which generally we use. Sequential pattern. Sequential pattern is that one agent does something. After that, it gives that output to another agent, and that takes that output to proceed further. So this is in a sequence. So first, until less, for example, let's talk about understanding a document. So understanding a document, there are two agents. One agent which reads the document. So first agent just read the document, and then second agent is translating it. Okay. So second, until as first one reads it, second one cannot translate. So this sequence. So one agent output goes to another agent input. So that is sequential. Parallel, if we can do some activities in parallel, that's parallel agents, where example is, let's say we have to book a travel. So one agent is doing a flight booking, another agent is doing hotel booking. You can do two things in parallel. So that's called parallel agent, where the input and output are not interdependent. Hierarchical orchestrator is something which I'm going to explain you. I think I'll tell you what exactly we are doing in Visualonics. So where you have a supervisor and you have multiple agents working for that supervisor to accomplish a big task. The fourth kind of is generator and critic, where first agent generates something and then second agent critic it. Means, for example, let's say the first agent is generating a translation. You are translating from Kannada to English. And then once that translation is done, what critic agent does, it look as an English text and it look at the translation, and it figure out that his translation is good or not. If not, it gives back to generator with an input that this is translation is not good, here, and then it regenerates it. So this is called generator critic loop, where you have two agents working together to accomplish a task. It's a very good concept, because agents are learning and improving each other here. Okay, moving on. So what is the most common enterprise pattern? Like I explained you, this orchestrator worker pattern is the most common pattern, because this solves a very big problem. It divides into smaller problems and it solves together. Okay. Okay, so how a production stack look like today? So you have orchestration. There are different kind of tools available. In each layer is 1 hour session. So I've just give you very high level so that you can go back and learn about this. So orchestration is done using LangGraph, Crew AI, Auto Generator, Google ADK. And then communication, like I explained, model context protocol, agent to agent communication, where two agents can talk to each other. MCP is primarily talking, agent talking to tools. So let me little bit touch on MCP so that you understand the concept. So usually LLMs cannot do mathematical tasks. If you say, because these are large language model, it is trained on whatever is given as an input data. If you ask it to do 10 multiplied by 10, it might give you 110. So for those kind of tasks where algorithm works better, you write an algorithm, right? You write a function which does, or for example, a multiply function, where you give input that what are the input 10 into 10, then it returns our output to the agent. So what we are telling to the agent, that whenever there is a math query comes in, whenever there is a multiplication query comes in, you go and get this thing done through tool. And this tool communicate with the agent using MCP, Model Context Protocol, where it will tell that how agent can communicate to MCP. Okay, so that's how the tools and agent work. Agent to agent is where two agents are talking to each other. Like I explained you this generator critic, where two agents are talking to each other to complete the task. Memory is Redis cache, Pinecone. There are multiple solutions available to work on the memory. Tools registry, custom APIs. Just I explain you that if there is a math function, then there is a custom API of math which agent can call. Function calling schemas, which is defined. Observability is the very critical thing which needs to be taken care, which nobody talks about. That if something goes wrong, how you will know what went wrong? So this Langsmith, Azure, OpenTelemetry, these are the tools which is used in agentic AI world to increase the observability. What do you mean by observability? It means that we observe the system, what it's doing, it's logging everything. What agent one is doing, what is the input, what is the output, what agent two is doing, what is the input and output. Everything we have to log, and we have to find all the trail, that who has done what. And unless you have it, you will not be able to answer that how this answer has come. So observability is very important. Governance is another very big issue, because the LLMs are trained on a huge amount of data. through the internet. So there is a privacy issue when you ask a question. For example, let's say you have asked a question that, okay, my salary is 1,000 rupees. I am working as a manager in so and so company. So what if this LLM use this data and then reveal, somebody else asks that in your company what's the salary of manager? So that privacy also comes into picture. So we need to have governance, we need to have audit loop, approval gate, circuit breakers to ensure that there is no privacy breach, or there is no a bias. Bias is another big thing which comes into picture. But again, these are separate topics. We can talk about it in detail maybe in future sessions. Any questions so far on this? I'll pause here. Okay, moving on. So how to choose the right multi-agent system pattern? So these are the questions you should ask. That, okay, is the task you can do in parallel? If yes, then you use fan out pattern. If no, then is review or validation needed? Means for each and every agent task, we need to review or validate. If yes, then we have to use generated critic loop, where you have two agents doing this task. If that is not clear, then is there a clear hierarchy of tasks that, okay, first this needs to be done, and then these three things we can do in parallel. This needs to be done in sequence. So we have clear hierarchy. If it is there, then you use hierarchical orchestrator worker pattern. And if not, then finally you can take a sequential pattern. Each agent output goes to the second one, and the second to third one, third to fourth one. This is how you choose. This is a standard way of choosing a right multi-agent system pattern. Any question on this? Cool. Moving on. So this is what I can actually give you an example about what we are doing in Visual Drawings. What we are doing, we are a software company, and then what we do is making robots autonomous. Our first use case is about drone. So what that mean is, as of now, you use a remote, and then you fly the drone. What we are going to do is we are going to put a intelligence inside the drone itself, that so that it takes the decision automatically. For example, if drone is being is flying and there is a tree in front of it and there is no controller, it will take that decision. It will perceive that's a tree, and it will take a decision to move up, move down, move left, move right. So that kind of intelligence we put there. Now I'll explain you how we are doing that. So we have an orchestrator agent, which is the flight controller, and it has three helper agents. One is mission planner agent. What it does, it actually plan the mission that I have to, let's say, they take an example of search and rescue. So mission planner agent tells that where to go, how to scan, and all that. So that is mission planner agent doing that task. Then safety override agent. If let's say there is a parameter we have defined that you have to search within 5 kilometers, it goes beyond 5 kilometers. So there is a safety override agent which stops the flight controller, which tells flight controller you're going out of the bound. So that's safety override agent. And there's a telemetry agent which tells where is your drone, what is the longitude, latitude of drone, what is the altitude of drone, where exactly it is. So I'm giving you very high level, but this is how you can use different kind of agents, and in this case 4 different agents working together to make a drone autonomous system. Okay, any questions on this? Yeah, moving on. So another example, I think, if I think the question Subhajit asked, right? What if the generative AI takes my job, right? So that is a real threat. If you don't know, I'll explain you here how. So how a dev team works. Currently, we have a tech lead who reads the specs, who read the requirement and understand what needs to be done. We have senior and junior developers who code, and then we have testing team who test the entire software, and then we have reviewer who review the code and review the test cases to ship the product. Now that can be done through agents. So I'm using MCP protocol, you can actually fetch those documents, and you can use different tools to understand what the specifications are. It can scope the work of different agent. And then once that scope is done, then using that scope, you can give it to coder agents to code it. In previous example, the spec reader agent can divide, then understand what needs to be done, and it defined the scope for 4 different agents: orchestrator, and then a flight controller orchestrator, and telemetry, and perceive, and on all those 4 agents. Coder agent actually code it. A tester agent tests it based on the test cases. It writes the test cases itself. And then finally, a reviewer agent can review the entire module, and you can ship the product. So, but can they do it themselves? No, we have to tell them exactly for each of these agents what to do. And that is the agent prompt, agent template, which you have to tell them how exactly you need to work on. So this is something where you need to understand how to use the Gen AI, how to create the agents, so that you can do multiple tasks by, and then all monotonous tasks can be done by the agents. So if you don't know how to use this agent, your job is in danger. But if you know how to write these agents very simple, then you can actually be a very high paid software developer. Any questions on this before I move forward? Okay, moving on. So now we will talk about what breaks in production. Looks very simple, but there is something which, based on my experience in last 10 years, that what nobody talks about, there's nothing there in the books, that what is breaking, right? What could break in production, which usually we ignore. Okay, so what are these? Context drift. If let's say you have an agent which it's doing multiple things, and you have huge context given to it, then it start forgetting the previous context, right? So for example, mm, if you ask a question and then you keep on asking questions, for example, you say, hey, tell me about drones, and then how drone works, what is flight controller, you keep on asking questions, that context keep on increasing, and then finally it reaches a point where it forgets what you asked earlier, and this is called context drift. So you have to ensure that when you are building your agent, the context need to be compressed separately, so that it does not go into drifting. You summarize everything and then give that context back, not the entire conversation. Okay, or periodic anchoring, re-anchoring is also the similar thing. Tools confusion. For example, if you have given a lot of tools to the agent, it will get confused at which one to use. For example, you have a math tool which does basic mathematics. You have another math one tool, math two tool, math three tool, which does different things. One is doing square roots, another is doing complex calculation. And if you're not telling agent which exactly tool to be used for which function, then it gets into wrong kind of tool use. So how to fix it? You don't give the full registry or full all the tools to the system. You give only what is specific to that agent. So for example, in our case, in drone case, that if we have an orchestrator agent, a flight controller agent, we only talk about flight control. We don't talk about the perceive or camera vision and things like that to orchestrator. That's the job of the perception agent. So you need to be very specific which agent, which tool it will use. You cannot give all the tools, all the algorithms, all the capabilities to all the agents, right? Other it will get confused. So shared state mutation. So that's, if you remember, when process in operating system processes, you have semaphores to control the resources. If two agents are using one resource, then it get into race condition, right? So that kind of introduction, that kind of mechanism we have to put in, right? This is where human comes into picture. Agent cannot do it themselves, right? So there is strict state ownership model per agent, which which need to be defined. And then finally, coordination failure. So you remember our generator and critic um, um, pattern. What if they keep on asking and it goes in infinite loop? It will never come, it will never give you an answer. So we have to have circuit breakers. When we have to stop, we have to say, okay, it's enough. Now we have to move forward. So we need to have mechanisms in the system so that agent do not take over the control. Okay. Any questions on this before I move forward? It's a little this context if tool confusion. These things are little, if you have worked on it, you will understand it better. But yeah, for now, you can just understand these are the concepts we need to take care of. Any questions on this before I move forward? Okay, moving. So what you need to ship and what you should not do. You should narrow the narrow the scope of each agent per role. Like I explained earlier, that each agent should be doing one specific task, not multiple tasks. You need to measure outcomes, not agent step, right? If you try to get into this, you token usage should be your main KPI. So if you guys have ever paid for the LLMs, each token, each word is this is how it is being paid. If you have 100 token, you have to pay more than if you have 10 tokens. So token usage is also important. Then you need to figure out how to reduce your query, or how to reduce your context to reduce the cost of the agent. So cost is very, very critical here. Audit trail on every decision hoop, right? I explained you about observability, where you need to have logs of everything that what is the agent output, and everything needs to be logged. Your agents cannot go in production without logging. Okay, removable orchestration layer. So they should not be very tightly coupled systems. Like explained you, if you go read more about MCPs that help, model context protocol that help you create loosely coupled agent chains, where you can remove one agent, you can plug in another agent without changing other interfaces, right? So that is something you need to take care of. You need to have not very tightly coupled tools and agents or agent to agent communication. It has to be using standard protocols like A2A and MCP. Human escalation part for edge cases. So they should be, like I explained you, generator critic. If let's say they keep on going in loop asking each other that okay, this is not good, that is not good, it will never give you an answer. So there should be an escalation path where you need to define when agents try to take control. Okay. Okay. Now this is the last section of this presentation. What you should do next? First thing you should do after going back, experiment using one single agent and understand about RAG. Okay, RAG is a simplest way of getting things done. Uh, Again, it is a different topic altogether. Plus tool use. So you should do that in 1 to 2 weeks, and it solves a very simple real internal task. After that, once you've done that, you go to orchestration, where you have 2, 3 agent pipeline. Use LangGraph or Crew AI, where you can do multiple parallel tasks with no manual glue. Means there is no human between, where two agents are working together to get things done. Then productionize. Observability, like I explained to you, everything need to be logged, evaluate, governance, MCP, that you should do in next 3 months. So until unless you go and do it, whatever you learn, you'll forget. So it's very important that you go and start doing these 3 things one after another, so that you'll remember these concepts in future. So what you need to, what are the resources? So read about Google's multi-agent design pattern. So is something you can Google, and then you can read about it. And then start with learning about LangGraph, Crew AI, auto generation, conversational models. So start about learning about that, and then watch about there are different tutorials about MCP A2A protocol on YouTube. Watch those protocol, and then if you need, then you can connect with me. Okay, so let's move back to our initial question. We didn't stop building software; we taught it to build itself, right? Now we're not giving instructions that exactly, we're not writing algorithm. What we're doing here, we are designing the system that it acts wisely automatically. So this is the change, the drift, the change which has happened in last couple of years, where we have moved away from software engineering to agentic AI kind of system. Okay, and this is my last slide. Any questions? Anyone has used any agent anywhere? And this is my LinkedIn. You can connect with me if you want, and I'll take questions now. Anything overall, anything related, not related, we can talk about. Any questions? Anyone?
Thank you, sir. As I think there is no question, you solved all the questions, and thank you so much for in such an insightful and inspiring session. We truly learned a lot from your experience and the knowledge you shared us with today. And it was very great opportunity for all of us to learn to learn and from your journey. Like, we are very grateful for your time and your guidance. Thank you so much, sir. Thanks.
Thanks, Madhulika, and thanks everyone for patiently listening to me. If let's say I understand it's like a lot of things to intake. If you have any questions, you can connect me over the LinkedIn, and then so this is my LinkedIn profile, and then I'll be happy to answer any questions. Okay. So if there is no question, then you can close the session. Thank you very much, everyone. Have a great day ahead. Have a good night.
Thank you, sir.
Thank you. Bye bye.
Thank you, sir.
Thank you, sir.